Hi, welcome to Math for All, where everyone can learn more about math. Today, we are continuing our adventure in solving linear equations. So far, we have learned to solve flat equations like this, and may I just say, excellent job with those. But now, we are going to solve stacked equations that look like this. Notice that x on the bottom? That causes us a little bit of trouble. And equations that look like this. These are two mischievous fractions that equal each other. Before we tackle these and successfully bring them down, please go to my website, MathforAll.net, and print out fill-in-the-blank notes that follow along with this video. Let's get into this. We solve these types of equations using an important principle. Whenever we see two fractions that equal each other, the diagonals also equal each other. Let me show you with two obviously equivalent fractions. We all agree that 3/4 equals 6/8. I just multiply the top and bottom by 2. Now, let's check those diagonals. I circle the 3 and 8 here, and 3 times 8 is 24. The other diagonals are 4 times 6, which also equal 24. Pretty neat. This property is officially called the means extremes, or equal proportions. I call it the butterfly because we can make a beautiful, colorful butterfly with our diagonals like this. Or we can call it the atomic symbol because it can also turn into one of those. Look out for those atoms. I don't think it matters what we call it as long as you know how to use it. I'll list the steps in how to solve these and then we'll use them to do some examples together. Step 1. Our first step is to notice when we have equal proportions. They can look like this with an x on the bottom. Once we get rid of that 7, we will have a fraction that equals a number. 5 over x plus 7 equals 4. Or we can have two fractions equaling each other like these. X plus 4 over 3 equals x plus 1 over 2, and 2x plus 1 over 4x equals 2/3. You can see the variables can be in different places, but it's no big deal. Step 2. Do the butterfly or atomic symbol. It's fun to circle the diagonals, but we must multiply each of them and set them equal to each other. Step 3. Solve for your variable the way you already know how to do. Now, let's solve some examples using our steps. 5 over x plus 7 equals 4. Step 1. We need to recognize this as a proportion. Honestly, this currently isn't a proportion. So let's go ahead and start solving this normally. We see what's annoying the x and decide to subtract from both sides like this. I'm left with 5 over x equals -3. It looks like a one-step equation, but that x on the bottom is really trouble. When the letter is in the denominator, we should use the butterfly. Step 2. Do the butterfly. Houston, we have a problem.
Houston, we have a problem.
We don't have diagonals to circle. But I do remember that this -3 has an invisible 1 underneath it like this. Now I can circle my wing diagonals and draw a little extra body to make a lovely butterfly. Multiply the diagonals, 5 times 1, and that has to equal the other diagonal of x times -3. I have 5 equals -3x here. Step 3, solve. The -3 is annoying my x, and it's multiplying, so I will get rid of it by dividing both sides by -3, like this. And x will equal -5/3. Nice! Ready for another one? Here it is. 5 plus 3x over x equals 6. Step 1. Again, this doesn't have two fractions, but that x in the denominator is Trouble City. we'll just put this 6 over 1, and then we recognize that we have equal proportions, and we will move right along. Step 2. This time we'll do the atomic symbol. Switch it up a little bit. We really don't want to get bored. Circle, circle diagonals, dot in the middle, and how about another oval here? Just enough distraction to make it fun. Multiply diagonals. 5 plus 3x times 1 stays 5 plus 3x equals the other diagonal of x times 6 is 6x. Remember, we want to get those x's to meet on the same side of the equal sign. I'm going to move the 3x over. Negative 3x slash. Then 6x minus 3x equals 3x. Now we're at 5 equals 3x. Divide both sides by 3 here and here for a lovely answer of 5/3 equals x, or x equals 5/3. See how this technique brings everything up, meaning I have a flat equation, so it doesn't matter if there are letters in the denominators. Now we'll do a few that definitely look like two equal fractions, but they've got messier numerators. Check this one out. X plus 4 over 3 equals x plus 1 over 2. We can succeed in step 1. We notice that we have two equal fractions, and we will continue on. Step 2. This one's got a little extra thing to remember. On the top and the bottom of fractions, there are invisible parentheses like this. When you see stuff added and subtracted on the top and bottom, you should just wrap them up in parentheses right away. Moving along, we circle our diagonals to make our butterfly wings. Then, bank the butterfly body and antennae here. That is very important for our math well-being. We have x plus 4 times 2 equals 3 times x plus 1. See why the parentheses are important? We have to distribute our numbers to both of those terms. We'll say that goes in step 3 since we're solving it now. This 2, even though it's after the parentheses, gets distributed to the x and the 4. So this side is 2x plus 8 equals 3 distributed to the x plus 1 for 3x plus 3 over here. I'll move the 2x over here, subtracting 2x on both sides. Slash. Then 3x minus 2x is 1x. Bring down the 8 equals and the plus 3. Let's get rid of the 3 by subtracting 3 from both sides. Slash. For an answer of 8 minus 3 is 5 equals x, or x equals 5. Super cool. You are doing amazing sticking with me. We have one more example to really solidify this. 2x minus 1 over 4x equals 2/3. Step 1, we have equal fractions. Check. Step 2, we remember we have invisible parentheses here, reminding us to distribute later. Circle diagonals. Decorate to make a chemistry atom, which looks amazing, and multiply inside the circles. 2x minus 1 times 3 equals 4x times 2. We'll move to step 3, where we do math. Distribute the 3 to both these guys. 3 times 2x is 6x. Then 3 times negative 1 is negative 3 on this side, equals 4x times 2, which is 8x. 6x minus 3 equals 8x. The 6x is going to move on over. Negative 6x here and here. Slash. 8x minus 6x is 2x. Negative 3 equals 2x. Get rid of that 2 in front of the x by dividing by 2 on both sides. Slash. Negative 3/2 equals x. X equals negative 3/2. That went pretty fast and it looks great. Congratulations on learning how to solve these special cases where the variables are on the bottom, or we have stacked equations, meaning equal fractions. These built on what you already know, with just a little butterfly or atom twist. Keep practicing your excellent algebra habits by printing out a worksheet at MathforAll.net and keep learning more about math. Ready for another one? Here it is. That one just cracks me up. Because they're probably like, no, not really.